Working with geoprocessing and modeling tools. This is module 6. The discussion we had last week was on starting GIS analysis, and this topic is kind of similar to it. We're going to explain what geoprocessing is. We're going to choose some appropriate geoprocessing tools for a task. We'll describe what a model is and show how to use one. We'll list some advantages of using a model, and we'll create, modify, and run a model during the exercise portion of the class. So, what is geoprocessing? Geoprocessing encompasses any operation that creates new data from existing GIS data. So that's an important thing to remember when you think about geoprocessing. If it's creating an output data set, it's a geoprocessing operation. So in computers, we do a lot of processing of data and information. In the GIS world, when we're processing geographic information, we call it geoprocessing. So it's readying our data for working with it. Oftentimes, the data that we work with is not in the perfect shape and size and extent that we need when we get it, so we have to process it to get it to better suit our needs. So, if you think back to the GIS analysis discussion that we had, the definition of GIS analysis said that GIS analysis involves visualizing and combining geographic data to derive new information. So it sounds a lot like geoprocessing, because geoprocessing is an operation that derives new data. So with analysis, we're talking about going from data and moving to more information. With geoprocessing, it's taking data and outputting more data. So you have to kind of think about the difference between data and information to help you better understand the subtle differences between what's just simply a geoprocessing task and what's actually performing analysis on your GIS data. So when you think about data, data are simply facts. And when we spend time processing, organizing, structuring, and presenting data in a given context, we're able to get more information from the data. So looking at data and better understanding data, organizing it, interpreting it, provides more information. So the difference between data is really the time you put into it and what you're deriving from it. So with geoprocessing, we can combine geoprocessing operations. We can make a collection of them that will allow us to automate a workflow as well as visualize it. So we can combine many geoprocessing tasks together to see a workflow and to analyze information through a workflow. So geoprocessing are often part of analysis. Geoprocessing tools are used at any stage of the analytical process, and we use something called models to plan and manage complex analysis. So the more data and information you have involved in an analysis, the more it makes sense to use a model to plan and manage and organize a large analysis. And there's a tool inside of ArcGIS that helps us to do this. So geoprocessing refers to any GIS operation in which new data is derived from existing data. When you manage and analyze your GIS data, you will typically geoprocess it at some point. So while working with GIS data in any GIS project, you're going to be performing geoprocessing operations on your data. It can be as simple as copying data from one database to another, importing data from one source to another. That's creating new data. So that's a simple geoprocessing operation. Copying a file. That's real simple geoprocessing. When geoprocessing is used for analysis, it usually involves combining two or more data sets to produce a new data set that will include some of the features and attributes from the inputs. So a real common thing we do is clip data. For instance, the North Carolina Department of Transportation has a roads layer of the entire state of North Carolina. And I wanted to make a map of Buncombe County. I don't need the roads for the entire state of North Carolina. So I use a polygon of Buncombe County to clip out just the roads I need. The output data set is a new roads layer of just Buncombe County. A clip creates a subset based on a polygon or a group of polygons, and it's like a cookie cutter operation. Another example would be, what if I wanted to make a map showing the Great Smoky National Park? It's in Tennessee and North Carolina. It straddles the border. If I wanted to use the roads layers from the Department of Transportation's from Tennessee and North Carolina, I'd have two roads layer that came together at the border. I would need to merge those into one layer, and then I would need to clip it to the Great Smoky Mountain National Park boundary. So that's an operation. That's two geoprocessing operations. I want to make a map of Great Smoky Mountain National Park, but it's in two states. So I get roads layers from two different states, I merge them together, then I clip them to that area. So that's processing my geographic information to get it ready to work with. Another operation is buffer, where we buffer a linear point or polygon type feature to create a proximity kind of polygon based on a distance. We can dissolve, union, and intersect. These are all other geoprocessing operations we'll discuss as we go on through the PowerPoint. So geoprocessing is often part of analysis that we talked about last week. And sometimes the line can be a little blurred in what's just simply processing your data and what's actually analyzing your data. But don't get caught up with that right now. It's all kind of part of a bigger picture of analysis. And the geoprocessing tools we use for analysis fall into three types of categories. Data extraction, which is some of the more simple types of geoprocessing. We have overlay operations and proximity operations. Data for extraction creates a new subset of features in one feature class based on the geographic extent of another feature class. So CLIP is a data extraction process, and it's the one that I was describing using the Buncombe County and North Carolina State Roads layer. CLIP reduces the size of your data set and therefore reduces processing time down the road. So we geoprocess our data to get it into the right extent that we need for a particular project, and that will reduce processing time because we're not working on as big a data set. When you're working with geoprocessing tools in ArcGIS, you'll see diagrams like this one that attempt to show what the tool does. You've got an input data set here, you've got a clip data set you're going to clip by, and you've got what the output is going to be like. And this is what it looks like in the help typically. Overlay operations are where information from different layers are combined to answer some kind of question. The new layer contains information from both input layers. An example of this might be combining parcels and zoning to get a layer with parcel owner and type of zoning. The types of overlay operations, two of them, are union and intersect, and there are many more than this depending on the type of license you have of ArcGIS. If you only have an ArcView or a lower level license of ArcGIS, you don't have as many overlay operations. Another good example of an overlay operation might be if you had a soils layer and a forest layer, and you wanted to determine what kind of soils were on what kind of forest. You've got this information in two separate layers, and the combination of them not only combines the polygons, but it combines the attributes as well. So in this example, you've got a parcel here that's owned by, say, Pete Kennedy, and you've got a zoning type here, and here's another parcel down here. And notice this parcel has split zoning down here. So someone who owns this parcel right here, it's in two different zoning types, and you learn that by doing an overlay operation to combine those. It combines it in the attribute table as well. For this simple example, it's easy to look at and say, well, I can just look at the data and see. But if you had, say, 200,000 parcels and you wanted to make a layer that had zoning type on every parcel in the attribute table, an overlay operation would be how you do that. The differences in the types of overlay operations here, union and intersect, have to do with what is maintained in the output layer. For a union, all features and all layers are retained in the output layer. For an intersect, it only retains layers in areas in common to the two layers. So it's a little bit more like a clip that combines information from the two layers. Proximity analysis, or the geoprocessing tools that help you to do this kind of analysis, involves finding what is near or within a certain distance of one or more features. We saw select by location last week, where you can select features based on a distance of an object. A buffer actually creates a feature that visually shows that area. So buffers are real common proximity analysis. We use it for things like buffering points. You might want to create a polygon every 100 feet around a point. You can buffer lines to maybe create a riparian stream buffer 300 feet around a stream. You could buffer a polygon to show a certain distance away from maybe a CVS store downtown. And then you could use that polygon to select the other features close to it. Buffers can be also multi-ring buffers. So you can have a buffer around a point every 100 feet for 300 feet out. And you can also buffer inside of polygons. So for polygons, you can buffer the outside of it. You can also buffer the inside of it. You can buffer the inside of it to do something like a no-wake zone close to shores of a lake, something like that. During a GIS analysis, geoprocessing operations are performed in a particular order to achieve a final result. This is what we think of as the geoprocessing process. A data set that contains the features and attributes of interest for the analysis is what you're commonly working with. ArcGIS contains many geoprocessing tools, thousands of them. I don't know the exact number. It actually depends on the license level you have. The higher license level of ArcGIS, the more geoprocessing tools you get. A geoprocessing tool performs an operation on an input data set and then creates an output data set. So you've got an input, you've got something that happens to that input, and it outputs new data. The output of one geoprocessing tool can be used as the input to another geoprocessing tool. When this is the case, the data set that is produced as an output from one tool and used as the input to another is called intermediate data. It's data that we're creating just to input into another tool to output more data. So this is where you should start to see that we have a lot of data that we create through geoprocessing. Some of it are just intermediate stages trying to get to the final data. We end up with a tremendous amount of data files in the GIS world, and at the end of a project, a lot of times you're throwing away some of them. Space is cheap now, so hard drive space you can store. You don't have to clean up as much if you're concerned that you might have to rebuild data to get back to the point you're at, but it's very advantageous to properly manage your files, manage them well, or you just won't know what all the stuff is to even know if you could delete it or not. So coming up with a good naming convention, good file and folder conventions is really important in the GIS world. File management is hugely important in everything you do with computers, and in the GIS world, maybe even more so. And I've got a 7 terabyte hard drive, or I've got a or server. I've got a 7 gigabyte. No, it is a 7 terabyte hard drive. I think I have a 700 terabyte server. So, we have a lot of space. So, a geoprocessing tool requires certain parameters in order for it to perform its operation. So, tool parameters can consist of the name and the location of the input data set. You got to tell the tool what the input data set is. You have to specify values to the geoprocessing operation. For instance, with the buffer tool, you have to tell it the buffer distance. Some tools require more information than others. And you also have to tell it the name and the location of the output data set. That output data set gets created. You give it a name and you give it a location. Remember from last week, we looked at workflow diagrams and how they help us to organize and plan a GIS analysis. We use workflow diagrams to show geoprocessing operations as well. And workflow diagrams actually get created by something called the model builder. You can build these graphical kind of workflows into a model. So here you see this example. They've got some creeks and they're buffering the creeks, and that output of that buffer is a polygon around the creeks. Then what they're doing is they're using that polygon around the creeks to clip the fire perimeter. So the output here is just the fire perimeter within 200 meters of the creeks. They've got this big fire perimeter and they want to find the fire close to the creeks, and so they buffer the creeks. They get some output data here that's just a buffer of the 200 meters close to the streams. That's intermediate data they use to clip the fire perimeter for the output data set of just the fire perimeter within 200 meters of the streams. So that's the geoprocessing process and a workflow right there. Analysis and geoprocessing steps, this is what you'll do every time. You determine the geoprocessing tools you need. You determine the order in which they should be run. You locate the first tool, open the dialog box, enter the tool parameters, including the input data sets, and run the tool. Then you step back up and locate the next tool, put in the parameters, and run it. You keep doing this until you've run all of the tools, and then you examine the final output and repeat some or all of the analysis steps as needed. So maybe you determine that a 300 meter buffer is not right. Maybe you needed to only do a 100 meter buffer after you've performed the steps in the analysis and look at the statistics. You're like, yeah, that buffer's not right. So you refine your analysis a little bit and run it again. When you're doing it this way, you're manually going in and running each tool. The geoprocessing framework in ArcGIS is all in Arc Toolbox. So we've seen Arc Toolbox a little bit, but not a lot. The number of tools you have depends on your license of ArcGIS. And there are also some common tools under the geoprocessing menu in ArcMap. So the geoprocessing drop-down menu has some commonly used geoprocessing tools, so you don't have to go into Arc Toolbox and look for them. You can add tools to that drop-down and take tools away. Individual tools are organized into what we call tool sets, and tool sets are stored inside of toolboxes. There's a toolbox for all the major categories of geoprocessing: data extraction, proximity, overlay. Within ArcGIS, you can create your own tools and store them in your own toolboxes. You can either put tools in existing toolboxes, you can put your own toolboxes in a folder on your local disk or network. You can also store tools and toolboxes inside of a geodatabase. So they don't have to be just inside of Arc Toolbox. This allows you to deliver a geoprocessing tool with a project inside of a database to a client. It allows you to organize frequently used tools for a particular project in a custom toolbox and keep them all in one place. That's really useful. In ArcGIS, we can combine geoprocessing tools into a model that allows us to automate these geoprocessing and workflows. So a model is a collection of geoprocessing operations that automatically execute in sequence when the model is run to produce a final output data set. Models automate your geoprocessing work and allow performing GIS analysis more efficiently. They allow us to run what-if scenarios so that we can change a parameter and rerun the model. And we build these models inside of ArcGIS using the model builder. So the what-if scenario is one of the greatest reasons to use a model. Say we perform this task where we have to combine a bunch of data sets, merging them, then we clip out a bunch of stuff, then we buffer some stuff, then we clip some stuff to that buffer. It starts to be a long geoprocessing task, and you could change one little parameter in there like the buffer distance and rerun the whole thing to determine to do what if scenarios. What if the buffer's 400 feet? What if it's 200 feet? How does that affect our final output? And you don't have to go in and run individual tools, 16 different individual tools to get that output from changing one little parameter in one of the tools. You just rerun the model and it just steps through. It buffers the creeks, it clips the fire to the buffer. This is a simple example, but they can be very complex as well. Model Builder is a graphical environment inside of ArcGIS that lets you create and interact with models. The building block of a model is called a process. And a process consists of a geoprocessing tool. So remember that a tool requires an input data set and it produces an output data set using specified parameters. A model is represented by a diagram that shows all of the processes or geoprocessing tools and the sequence in which they run. The connected arrows show you how elements and processes are related to each other inside of the model. A model really reflects a geoprocessing workflow. The output of one process is often used as the input for another, that intermediate data. And models can be mirrors of simple or complicated geoprocessing workflows. So the previous slide showed us a simple geoprocessing workflow, and the example below on this slide shows a more complex geoprocessing model that you can't really see it that well. There are many examples on the ESRI support site of models that you can download that other people have built. So you could look at some more complex ones, and you're going to build a pretty complex one in a couple exercises. A couple modules, I mean. This module doesn't have any real complex geoprocessing. In a model, the way that these elements are symbolized tell you something. When the elements are white, it's not ready to run. Most likely, the geoprocessing tool has a parameter that needs to be entered. You haven't told it the buffer distance or something like that. When they're colored, they're ready to run, and when you see these drop shadows, that means that the process has been successfully run. So why do you use models? They provide a big picture view of a project. They're reusable. They run seamlessly and faster once you build them. Processes can be run individually. Models make managing intermediate data easy, and models can be shared.